Today we're going to look at graphing polynomial functions. So we're going to look at the graph of y equals x cubed plus x squared minus 9x minus 9. And we're going to do this all without a graphing calculator, so we're just going to kind of get a general shape. We're going to find some key features, x-intercepts, y-intercept, and then we're going to kind of look at the domain, range, and end behavior of this polynomial function. So let's start off with the easy one, and that's the y-intercept. Y-intercept is always found by letting x be 0. So if I put 0 in for x, 0 cubed is 0, 0 squared, 0, minus 9 times 0. So I'm just left with this negative 9. It's always going to be that constant term in any polynomial. So 0, negative 9 is going to be my y-intercept. To find my x-intercepts, I'm going to need to set y equal to 0 and then factor. So I'm going to get the equation 0 equals x cubed plus x squared minus 9x minus 9. So this is a cubic. So there's a bunch of techniques to factor a cubic. I'm going to use the box method since there's 4 terms and it looks like there's going to be some common stuff to pull out. So I'm going to put the first term x cubed, x squared, minus 9x, and negative 9. X cubed and x squared have a common factor of x squared that I can pull out. X squared times x is x cubed. X squared times 1 will be x squared, so 1 goes up there. And then finally x times negative 9 is negative 9x. Check to make sure the box worked. The last box has to check out as well. So negative 9 times 1 is negative 9. So that leaves me a couple of factors, x plus 1. We always set each factor equal to 0. And then x squared minus 9 equals 0. So the first one, when I solve, I get x equals negative 1. So that gives me an x-intercept of negative 1, 0. Second one, I could factor into x plus 3x minus 3, or add 9 in square root, which I'm just going to do it that way. X squared equals 9, take the square root. Don't forget it produces 2 answers, so plus or minus, and the square root of 9 is 3. So I get my other x-intercepts at negative 3, 0, and positive 3, 0. Okay. So there's some key points. I found kind of 4 key points. And lastly, what I'm going to do is going to do end behavior, which really should match up with these key points. And you can look to other videos I've produced on kind of general polynomial end behavior. But the idea this is a cubic. Okay, so cubics, the ends go in opposite directions. And since the leading coefficient is positive, this graph's going to start low and end up high. Okay, so my end behavior for an odd degree polynomial with a leading coefficient that's positive will be as x approaches negative infinity. That's where it's starting. The y is going to be down at negative infinity, so it starts low. And then it ends up high. So as x approaches infinity, y approaches infinity. It really goes back to a linear. A linear starts low and ends high if the slope is positive or if the leading coefficient is positive. Alright, so putting all those things together, I've got some key points. Y-intercept 0, negative 9. So I'm going to pull down this graph. So down 1, 2, 3, 4, 5, 6, 7, 8, 9. So down here. My x-intercepts are at negative 3, negative 1, and positive 3. 1, 2, 3. Now these are all single x-intercepts, so that means the graph is going to actually pass through the x-axis. It's going to cut through as I draw this. Okay. Now again, without either calculus or a graphing calculator to help me out, I'm not going to really know, for sure how low this graph is, exactly when these graphs kind of turn and change directions. So just a rough shape is what we're looking for. Alright, so based on my end behavior, as x approaches negative infinity, my graph's going to start down low. So I'm going to start my graph down here somewhere. And it's going to come up, get to that first x-intercept, go through it, then it's got to turn and come back through the other x-intercept. So I'm going to come down through here, hit my y-intercept. Again, I don't know how low it gets before it turns around. I'm not concerned unless I have a calculator to do that. And then it's got to turn and come back up through this last x-intercept and finish up towards infinity. Okay. And so there's a rough shape. Again, what we're looking for from you guys is to find the y-intercept, the x-intercepts, and that end behavior, so you get a general look of what that cubic polynomial is. So finally, domain. Domain, as we can tell, the graph keeps going forever. All polynomials are going to have a domain that's all reals, or from negative infinity to infinity, depending on your choice of notation. And ranges for cubics, again, I've got arrows on both ends. You can check that end behavior. One of the y's is at negative infinity, and the other y is at positive infinity. So my range also goes from negative infinity to positive infinity. Okay. So there's how we graph a polynomial. Again, key things we're looking for is the y-intercept, let x be 0. The x-intercepts, let y be 0. Typically you're going to have to use one of our factoring techniques. Plot those x-intercepts, use your end behavior, and sketch a rough picture of the graph.